So, yes, after these two very nice presentations, Valeria with the empathy for pain and Cass with the very nice data and also the dance story, I was trying to think how to make my presentation fun, but I don't think it's possible. I'm going to present a couple of studies that I've done during my happy postdoc years. And it is about the control of imitation, and in particular, the imitation of simple movements such as this and this. Okay. Since the discovery of the mirror neurons and after 20 years of research on humans, we now know that observing an action activates a corresponding motor plan in the observer. And this motor mirroring has consequences at the behavioral level. We have shown that humans have a tendency to imitate others, imitate speech, imitate postures, imitate movements during social interactions. And this imitation phenomenon has been studied a lot, both in social psychology, using ecological settings and real social interactions, and in the lab by cognitive scientists. And in the social psychology domain, this is called social mimicry. In the lab, we call this automatic imitation. So humans have an automatic tendency to imitate movements of others and actions. How do we study this in the lab? Well, we have seen a little bit of TMS today, so we can apply single pulse TMS to the primary motor cortex while participants are passively observing movements or actions performed by others. And we can really find very specific motor mirroring by using single pulse TMS and measuring the amplitude of motor evoked potentials. We know that the amplitude of motor evoked potential can be taken as an index of cortical spinal excitability. So it tells us how much our M1, our primary motor cortex, is activated while we look at visual stimulus. And what we can observe is that, for example, if I look at the screen and I see a hand moving the index finger of the participant will be more active with respect to when the participant observes a different movement, which means at the level of MEPs, it means more active means a higher peak-to-peak amplitude, so higher MEPs. Going a step forward, we know that this automatic tendency to imitate others can also interfere with our own behavior. So it can actually be detrimental somehow when the observed movement or action is incongruent, different from what the action we intend to perform. So there is a sort of a conflict or incongruency between the action that I observe and the action that I want to perform. And in the lab, there is a task that has been used a lot, which is called the imitation inhibition task, that show us this effect of interference by action observation. So here participants are instructed to look at the screen and to respond by two alternative finger movements to a cue that is not social at all. It is, for example, a number. So, for example, here subjects have to lift their index finger when they see the number 1 and lift the middle finger when they see the number 2. But together with the cue, so the number, a hand also appears on the screen that performs a movement that can be congruent or incongruent with respect to the movement that the participant has to perform. So, for example, here the subject has to lift his or her middle finger, and the corresponding hand movement is presented on the screen. And here the participant has to lift the middle finger while an index finger movement is presented on the screen. And what we consistently observe is that reaction times are faster in the congruent condition as compared to the incongruent condition. And the interpretation of this effect that has been replicated a lot in the literature is that in the incongruent condition, we need to overcome our automatic tendency to imitate the movement on the screen to perform the correct action, even though we have to remember that the movement presented on the screen is totally irrelevant to the task. So automatically, so we have a tendency to imitate others, and this can also interfere with our own behavior. Luckily enough, we do not imitate others all the time, which would not be very helpful for social interaction and our survival even. We know that imitation, as Valeria was also mentioning, it's the same for other, even for empathy for pain, for example. Imitation is can be modulated, and it is modulated by social factors. For example, it seems by for example, how I feel socially engaged with somebody. For example, I would tend to imitate more, or if I feel more similar to somebody I'm interacting with, I will imitate more, etc. But this is also, imitation is also flexible. So I'm adapting my action very quickly based on the context, as for example, in the case of complementary actions, where a complementary and the identical action has to be performed to interact with others. So to show this flexibility of the mirror responses, we tested the flexibility of the mirror responses through simple instructions. So here we stimulated M1. We recorded from two muscles, the FDI muscle that corresponds to index finger, and the ADM muscle that corresponds to the little finger. We record MEPs while participants are passively observing index finger and little finger movements on the screen, passively observing. However, before each session, we give them task instructions that are either mirror instructions or counter mirror instructions. So in the mirror instructions, for example, we tell them, okay, if you see an index finger movement, you have to perform the index finger movement. And if you see a little finger movement, you have to perform the little finger movement. And in the counter mirror instructions, we tell them, if you see the index finger movement on the screen, you have to perform a little finger movement. And if you see a little finger movement, you have to perform the index finger movement. But then we tell them, okay, now you only observe, you will perform the task at some point when the probe stimulus comes. So they passively observe, but they have in mind the fact that they got instructions and they have an action to perform, and this action is mirror or counter mirror. During the passive observation of the stimuli, we deliver a single pass TMS, and now we can look at what happened at the level of the MEPs. So here, when participants receive mirror instructions, we can see here the preference for each muscle, the preference for the index finger and the little finger image. And we see that for the FDI muscle, the index finger of the participants, we see higher MEPs when the index finger movement is presented on the screen with respect to when the little finger movement is presented on the screen. And the reverse is true for the ADM, which is the little finger movement. Are you still there? A lot of index finger, little finger. This is the classic, we never use this anyway in real life, but in the lab a lot. And this is the classic mirror response. And now what we observe is that when we give them counter mirror instructions, we are able to suppress the classic mirror response. Now, I don't want to say here that we destroy them, shut up the mirror neurons, but I want to say that short-term stimulus response associations given by instructions can somehow allow us to recode the visual stimulus so that they cover up the mirror response. Okay, so to show that indeed responses to actions can be highly flexible. So one question that I was interested in is in the lab of Marcel Brass, of course, was how we do control automatic imitation. So we said that when we observe an action, the corresponding motor plan is activated in the observer. So when we are also involved in a task, we will have all the time different motor representation. One that is associated with the action that I observe, and one that is associated with the motor plan of the action I want to perform. And this should be virtually indistinguishable at the motor level. So how the brain help us control this self and other representation? It is an interesting question, also because it's been allow us to relate imitation to other social cognitive abilities such as theory of mind and empathy. And so in the control of imitation, especially during the with the use of imitation inhibition task, what has been shown is that whenever there is a conflict between self and other, such as in the incongruent condition of the imitation inhibition task, a series of areas are active, especially the right temporoparietal junction and anterior medial prefrontal cortex, that are very famous areas because are also part of the theory of mind network. So, but the question is, what is the role of, well, here I focus on what is the role of these areas, how they can implement the control of self-other motor representation. And especially I focused on the right temporoparietal junction, because I wanted to know what is the TPJ doing when she's lighting up in the scanner when during the task. In effect, the control of imitation can be, in the case of a conflict between self and other, can be performed in two ways. In one way will be to inhibit the mirror response, so inhibition of imitation tendency. And another possibility is that the system simply boosts our intended action, so our to be performed action. So I wanted to dissociate between these two aspects. And to do so, I used a combination of TDCS, so electrical stimulation, and single pulse TMS. So electrical stimulation, TDCS, I wanted to see the time, sorry. I didn't start, okay. Was used to boost activity in the right temporoparietal junction. And after this, I used the single pulse TMS to measure MEPs during the imitation inhibition task. And why I did that? Because so here participants perform the imitation inhibition task. Again, move index finger or middle or little finger when you see number 1 or 2. And the interesting aspect of using measuring MEPs during the task is that we could somehow isolate these two components, the execution component and the pure mirror or automatic imitation. So here, for example, we have the two, so we are recording from the FTI, so from the index finger, and the index finger is involved in the response, so it's also responding. And here we can see, we can compare the congruent and incongruent condition, and we expect higher MEPs in the congruent condition because have the to be performed movement that is congruent with the movement that is observed. So higher MEPs. And here in the incongruent condition, participant has to move the little index finger while he observes the little finger. So it's incongruent, and I will have smaller MEPs. And this part relates to the intended action performance. So it's a congruency effect that is similar or parallel to what we observed at the level of reaction times. But the interesting part, and that is that we could also look at the same muscle when it was not involved in the response. So for example, here, participants had to move their little finger to respond to the cue. And we can look at what happened at the FTI when it is actually doing nothing. And here we can measure, as I said, the pure mirror response. So we can see the difference between the incongruent condition when the index finger is on the screen and the congruent condition where the little finger is on the screen. So here we expect higher MEPs in the incongruent condition as compared to the incongruent condition as an index of pure mirroring or imitation tendency. So will the stimulation of the right TPJ affect the execution component, boosting our intended action, or will rather help us inhibit the mirror tendency? This is the logic, although it is a bit complicated to explain all the conditions. So which of the two components will the stimulation of the right TPJ affect? So what we look at the pure mirror response, automatic tendency to imitate, and what we see is that there was no difference between the anodal stimulation of the TPJ, so boosting activity of the TPJ, and the sham. So stimulation of the TPJ leaves completely unaffected the mirror response, okay? But here in the execution condition, we can see that anodal stimulation of the TPJ induced a suppression of the congruency effect. So there was no difference anymore between congruent and incongruent conditions. And especially the MEPs in the incongruent condition became larger. So this suggests that indeed TPJ, at least in this task, is not involved in inhibiting the mirror response, but rather help us boost the intended action. So okay, so we confirmed the critical role of TPJ in the control of imitation. We got some more information about the possible role of this area in the control of imitation, but of course, other recent meta-analysis show that TPJ is not the only area involved in the control of imitation, and also pointed out to other regions, such as the dorsolateral prefrontal cortex, that might actually play a role in the control of imitation, pointing to the classic dissociation between domain general and domain specific processing, questioning whether the control of imitation is really something that it's really related to something social, or rather to general cognitive control. So more studies are needed to clarify the contribution of all this big network in the control of imitation. Okay. Question about
I don't know whether you are interested or not in this question. If you maybe, I mean, I know that you totally work with brass before we are aiming to get started. I don't know the literature about this actual innovation task. But I remember a similar question I asked to the question is, you say, okay, I really work with the different automatic and tendency to imitate others. But we would find similar effect if non-active or the subject becomes very but simply, for instance, if subject task in which you present a work, for instance, if you read little finger, then you raise the count. But if you see, so it doesn't create a conflict and a difficult task which nothing you see and what you do is not really the same. But the question is, would you find the same thing, the difficult task in which you create a conflict? Well, dimension without, necessarily involving automatic imitating thing.
So yes, that's of course an interesting question. Not me, but some colleagues try to. So, for example, in the classic task, there is beside the imitation compatibility, there is also a spatial compatibility. No, with respect to the hand, one is finger is on the right, and the other one is more to the left, etc. So they try to control for these components that are not really imitative, but more like spatial, etc. And the effect is still there. I mean, it's very hard because with words that evoke actions, we know that they can still activate the motor system. So, but yeah. But for example, what I can say is that I tried, it's unpublished, I tried to correlate the effects of the imitation inhibition, the congruency effect in the imitation inhibition task with a Stroop effect, for example, so another kind of conflict task, and they do not correlate. But yeah, the question of whether it is purely imitation or it is just a conflict. And but this is interesting because another thing is that so far, is okay, the detection of the conflict in the imitation inhibition task seem to activate areas that are not really the classic cognitive control areas. Here, this last meta-analysis showed that some areas like the dorsolateral prefrontal cortex are active, but in general, you will find more TPJ, anterior medial prefrontal cortex, that are not really the classic conflict areas. So this also suggested that maybe something a bit different from classic conflict, but yeah.
Now we should have